In this video, we'll be completing guided examples for 6.3 sampling distributions and estimators. You can follow along starting in page 8 of your 6.3 sampling distributions and estimators guided notes. A family has 3 children with ages of 4, 5, and 9. Let's consider the population as 4, 5, 9. If 2 ages are randomly selected with replacement, we want to list the possible different samples along with the probability of each sample. So because it's with replacement, that means that we could put the numbers 4, 5, and 9 into a bag, and I'll draw out one number, say it's a 4. I'm going to put that number back in the bag before I draw the second numbers. So that means on my second draw, I could still draw a 4 or a 5 or a 9. And when I list all the possible different samples we have right here, you could get 4, 4, 4, 5, 4, 9, 5, 4, 5, 5, 5, 9, 9, 4, 9, 5, and 9, 9. These are all independent, and each of these samples is equally likely to occur, so the probability of each of these individual samples is 1/9. We're going to look at the sampling distributions for the mean, standard deviation, variance, proportion of evens, and range for this data. So in order to do that, we need to find for each sample each of those statistics. Find the mean for each value, or for each sample, we're going to take each of the values in the sample, add them up, and divide by 2. So the first one we have is 4. The mean of 4 and 5 would be 4 plus 5 over 2, giving me 4.5. Go ahead and find all of the sample means. Sample means are as follows, going down the column: 4, 4.5, 6.5, 4.5, 5, 7, 6.5, 7, and 9. Note that some of them repeat. Next, we'll find the standard deviation for each of our samples. Note that the standard deviation tells us, on average, how far away a data value is from the mean. So when we have a sample of 4, 4, the mean is also 4, and neither of those data values shy away from the mean at all. So anytime we have the repeat numbers, we're going to have a standard deviation of 0. So that goes for 4, 4, 5, 5, and 9, 9. We can use a formula to find the rest, or we can simply plug them into our calculator. In your calculator, press Stat, Edit, and then in your List 1, you can clear the list by highlighting it and press Clear if there's anything in there. And then you're going to type 4, Enter, 5, Enter. Now you can go ahead and press Stat and go over to Calc and do 1 var stat for List 1, which is second 1. Frequency you can just delete and then press Calculate. And we get our sample standard deviation is S of X, and that's 0.707. The standard deviation of 4 and 5 is 0.707, but that'll also be the standard deviation of 5 and 4. What you're going to do is go ahead now and you're going to type in 4, 9 and find the standard deviation for that, and that will be the same as the standard deviation for 9, 4. And you're also going to type in 5, 9 and find the standard deviation for the sample 5, 9, which will also be the same as 9, 5. You can see the standard deviations down the column are 0, 0.707, 3.536, 0.707, 0, 2.828, 3.536, 2.828, and 0. Now to get the variance, you're just going to simply square your answers from the standard deviation column. Go ahead, fill those in, and check your answers. Your answers for variance down the column are as follows: 0, 0.5, 12.5, 0.5, 0, 8, 12.5, 8, and 0. Now we need to find the proportion of evens. Out of each sample of 2, how many are even? The first, we have 4 and 4, so that's 2 out of 2. So the proportion would be 1. Next, we have 4 and 5. That would be 1 even out of 2. So the proportion's 0.5. Next, we have 0.5 again. And 0.5, 5 and 5, the proportion would be 0. They're both odd. 5 and 9 would also be 0. And then 9 and 4, we have 0.5, or 1 out of 2. Then we have 0 and 0 again. Our last statistic is the range, which is the maximum minus the minimum of each data set. So the range of the first would be 0. Next, we'll have 5 minus 4 is 1. And then 9 minus 4 is 5. 5 minus 4 is 1. Then we'll have 0 for 5 minus 5. 9 minus 5 is 4. 9 minus 4 is 5. 9 minus 5 is 4 again, and then we'll have a range of 0 for the last one. Now we're going to make a sampling distribution for each of these statistics, so we'll continue to refer back to this table. First, we are going to describe the sampling distribution of the sample mean by creating a table summarizing the probability distribution of the sample mean. You'll notice on our chart on the previous page, some of the sample means repeated. We're going to create a condensed table for these sample means. In this condensed table, you can see that the sample mean of 4 has a probability of 1/9 because only one of the samples resulted in a mean of 4. You can see the sample of 4.5 has a probability of 2/9 because 2 of the samples on the previous page resulted in a sample mean of 4.5, and so on as you go through the table. You'll notice the probabilities in the table add up to 1. Now we need to find the mean of the sample means, or the expected value. To do that, what we're going to do is we're going to take each mean and we're going to multiply it by the probability of that mean occurring. And what we'll find is the sum of each x bar times p of x bar. And that's our expected value for the means. So I'll take 4 times 1/9, and I'll get 4/9. 4.5 times 2/9, I'll get 9/9. 5 times 1/9 is 5/9. 6.5 times 2/9 is 13/9. 7 times 2/9 is 14/9. 9 times 1/9 is 9/9. And I will add those all together. When I add them all together, I get 6. So the mean of the sample means is 6. What I have to do is compare that to the population mean. So the population had the numbers 4 and 5 and 9. So I'll add up those numbers and divide by 3. That gives me 18 over 3, which is also 6. So the population mean and the mean of the sample means are the same. That means we can say, yes, the sample means target the population mean, and we have an unbiased estimator. So the mean is an unbiased estimator. For our next example, we're going to be looking at the sample standard deviations. We're going to create a table that summarizes the probability distribution of the sample standard deviations. So we're going to condense the table that we had on the previous page so that we don't have repeats. So in this case, we have the sample standard deviation of 0 has a probability of 1/3 because there were 3 samples that result in a standard deviation of 0 out of the 9 total samples. 0.707 has a probability of 2/9 of occurring. 2.828 has a probability of 2/9 of occurring, and 3.536 has a probability of 2/9 of occurring. The total of the probabilities is 1. Now we'll find the expected value in the same way. We'll take each standard deviation and multiply it by its probability, and then we're going to find the sum of each standard deviation multiplied by its probability, and that's our expected value. So I'll have 0 times 1/3 is 0. 0.707 times 2/9 equals 0.157. 2.828 times 2/9 equals 0.628. And 3.536 times 2/9, the sum of these values is 1.571. So the mean of the sample standard deviations, the expected value of those sample standard deviations is 1.571. We need to compare that to the population standard deviation. In your calculator, press Stat, go to Edit, and then in your list 1, you want to put the 9, 5, and 4. Remember 9, enter, 5, enter, 4, enter. Now you can press Stat and go over to Calc and select your 1 bar stat and go ahead and calculate. Now we're looking for the population standard deviation, which is sigma x, so 2.160. We can see that 2.16 is not equal to 1.57. So the sample standard deviation does not target the population standard deviation. That's a no. And therefore we can call standard deviation a biased estimator. Now we'll make a sampling distribution for our sample variance. So we're going to create a table that summarizes the probability distributions of the sample variance. Go ahead and create your table and then check in with me. You can see the sample variance of 0 has a probability of 1/3. The sample variance of 0.5 has a probability of 2/9. Sample variance of 8 has a probability of 2/9. Sample variance of 12.5 has a probability of 2/9. And the total is 1. Now what we need to do is find the expected value. So we're going to take each of our sample variances and multiply it by its probability. And then we're going to find the total of all of those to get our expected value. So we'll get 0, 1/9, 16/9, 25/9. And when we add these numbers up, we'll get 4.67. Now to find our population variance, we're going to take the population standard deviation of 2.16 and we'll square that number. And here we'll get 4.6656. I should note that the 4.67 we got for the sample variance is actually 4.6 repeated. So they're not exactly the same number because we did have to round at some point, but they are close enough where we can say that the sample variances target the population variance. That's a yes, and we'd say variance is an unbiased estimator for that reason. Our next example is a sampling distribution of a sample proportion, and I would encourage you, if you're feeling comfortable now, try this one out on your own and then just check with the video. So pause the video now if you're comfortable. If you're not quite comfortable yet, just hang on and we'll go through this one together. The sample proportions for evens were 0, 0.5, and 1. And for 0 and 0.5, the probability was 4/9 for each of them. And there was only one sample that resulted in a proportion of 1 for evens. So the probability of that would be 1/9. Note that all the probabilities add up to 1. Now we need to find our expected value. So we're going to take each sample proportion and multiply it by its respective probability. So we'll have 0 times 4/9 is 0. 0.5 times 4/9 is 2/9. And 1 times 1/9 is 1/9. When I find the sum of each proportion times its probability, that's my expected value, and I get 3/9 or 1/3. We can say that that's 0.3 repeated, or for the purposes of this, we'll say 0.333. Now, to find the population proportion in this case, we're going to take 4, 5, and 9 is our population. That's 3 items, so our denominator is going to be 3. Our numerator would be 1, because there is 1 even out of the 3. Now, our exact answer for the sample was also 1/3. They're both 0.3 repeated. So these are equal. Because the sample proportions target the population proportion, meaning one is equal to the other, we can say that we have an unbiased estimator here. For our final example, we'll do the sampling distribution of a range. And once again, if you're feeling comfortable, go ahead and pause the video, do out the whole problem, and then check your answers with us. Here on the right, you can see our condensed table. The sample range of 0 has a probability of 1/3 because 3 of the samples had a range of 0. The sample range of 1 has a probability of 2/9. 4 has a probability of 2/9, and 5 has a probability of 2/9. Now we need to find the expected value for our range. So what we're going to do is we're going to multiply each of these numbers times its probability, and then we'll add them all up. When I add up 2/9, 8/9, and 10/9, I get 20/9. The mean of the sample ranges is 20/9, about 2.2 repeated. The population range would be the maximum population number, 9, minus the minimum, 4. So 9 minus 4 equals 5. 2.2 repeated and 5 are clearly not equal. So we'd say the sample range does not target the population range, and therefore range is a biased estimator.